Okay, this is lesson 5.7, which is still graphing inequalities. Um, However, today we're going to convert them first. So today is the same as yesterday, except in order to graph anything, a line or an inequality, it must be in slope-intercept form. Okay, and so I've added this to my checklist. Is y isolated? So that's going to be the first question that you ask yourself. Then we'll go through these. I've annotated as well. Can y equal the line of solutions? If it equals it, then you include the line by drawing a solid line. If it does not equal it, then you don't include the line and you draw a dotted line like that. Y greater than, I've added these annotations. Greater than, you shade up. Less than, you shade down. And then you can test a point. So let's do the first example. This is not in slope-intercept form, so we need to get it there. And that means that we need to isolate y. So we'll first move the other term by subtracting it from both sides. We're left with 6y is greater than or equal to negative 3x plus 24. Just like an equation, if we want to isolate y, we'll divide by 6. Y is greater than or equal to negative 1/2 x plus 4. Now I'm going to go and graph it, but I'm only going to plot the points first. Go to my y-intercept of 4, count my slope of negative 1/2, down 1, right 2. I'll put several points. Now, before I draw my line, I'm going to make some notes about this sign. This says y is greater than or equal to, so it does equal the line. It will be solid. Then it says it's greater than or equal to, so I'm going to shade down from the y-intercept. So I'm going to draw a solid line with my ruler. And then I'm going to go to my y-intercept. I'm going to shade down. So everything below the y-intercept. Okay. Let's check these points. Is 3, 4 a solution? Right? 3 up 4. 1, 2, 3, 4. It's not a solution because it's over here in the non-shaded region. Only these are solutions. Is negative 4, 6 a solution? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. This point right here. And I'm not really sure about it. However, it's on the solid line. So remember, the solid line means it's included in the solution. So yes, it is a solution. Is negative 4, 3 a solution? It's in the shaded region. So yes, it is. Let's move on to example 2. Example 2, I have changed. Okay, I changed it to 2 times the quantity 3 minus y is greater than x. Okay, so we'll go ahead and we're going to distribute the 2. We'll go ahead and subtract 6 from both sides in order to isolate y. And lastly, we're going to divide by a negative 2. We're dividing by a negative, so I'm going to change the sign first. Y is less than negative 1/2 x plus 3. Graph the y-intercept first. Count the slope next. Down 1, right 2. Now go and analyze that sign. The sign says y is less than. So it's just less than, so it'll be dashed because the line is not included. And it's less than, so I'll shade down. So I'll draw a dashed line. Then I'll go to my y-intercept and shade down. Anything in that region is a solution. 0, 0 in the region, so yes, it's a solution. 5, 0. 1, 2, 3, 4, 5, 0. I'm actually not sure, so I'm going to test the point really quick in the original. Y is 0. X was 5. So 2 times 3 is 6 greater than 5? It is. So sometimes when it's really close like that, you're going to want to test it just to make sure. 0, 5. 0, 1, 2, 3, 4, 5. That's not in the shaded region, so it's not a solution. Last one, the y is over here. I really want it on the right side, so I'm actually going to add that first. 2y plus 5x plus 2 is greater than negative 6 plus x. Now I need to move both of these over here, and I'm actually going to do that in one step. I'm going to subtract 5x from the x. I'm also going to subtract 2 from the 6. You're left with 2y is greater than negative 8 minus 4x. Last step is to divide everything by 2. Y is greater than, I'll write this term first, negative 2x minus 4. Go ahead and plot your y-intercept first. Count your slope. Is that right? Yeah. Okay. This is going to be a dashed line because it's not going to equal it, and I'm going to shade above. Okay, so it'll be a dashed line, and I'm going to shade above the y-intercept like that. Is 2, negative 1 a solution? Yes. Is negative 3, negative 5 a solution? No. Negative 2, 0. So here, it's a point on the dashed line, and since the dashed line is not included, then negative 2, 0 is not a solution.